In this lecture, we'll see the application of a ideal diode. So we'll recap fastly. So whenever anode voltage is greater than the cathode voltage, or positive terminal voltage is greater than the negative terminal voltage, the diode is in forward bias, or the diode is on. So whenever the diode is on, the current flows from anode to cathode only. In reverse bias mode, that is whenever negative terminal voltage is greater than the positive terminal voltage, that it is in reverse bias, that is it is off. So that is open circuit. So this is the ideal characteristics, current versus I versus V. So whenever we apply V greater than 0, the current flows. Whenever V less than 0, it will be in reverse bias, that is open circuit, no current flows. Here forward bias and current flows. Right now, there is a very good application. We will not say application, it's like a switch application. So if you in gate, so you will have so many problems on this concept. So I will take one example how the gate question will be formed. So this is example of a gate problem only, already came in gate. So it is like this. Suppose there is a diode D1 and some resistor 1 kilo ohm, and here I have given some 8 volts. In this case, suppose diode D2 is there. Here I have given 3 volt, and there is a 1 kilo ohm resistor, and these two is connected to one terminal, and this terminal is connected to one more resistor, maybe 10 kilo ohm. So what we need to find, identify which diode is on or which diode is off. So this is the question. So to solve this question, so it's very easy to solve this question. So what we will, if in this case, if they said or if they ask, assume that diodes are ideal. So for practical conditions, that also we will discuss, but not now. Now how to solve this type of problem is, there will be two types of methods will be there. So one method is short circuit method. So this is one method. Second method is open circuit method. Some problems will be easy to use one short circuit method. One type of circuit is used. If you use open circuit method, it will be easy to identify which diode is in forward bias. So first we will see for this short circuit method what is the assumptions or what we need to take. In short circuit method, so we need to assume diode is in forward bias. We need to assume first. The moment diode is in forward bias, the equivalent model will become, equivalent model is simply short circuit, and the current flows from anode to cathode. So we will assume like this, and we will see if the current is flowing from anode to cathode. So whatever we assume, that is right. So we will say it is in forward bias. But this is the first condition. But if this current I is moving, from reverse, that is cathode to anode, so we will say that diode is reverse bias. So it's very easy if you go this type method, right? So now we will apply this method to the circuit. If I take again the circuit, this is 8 volt. Here diode D1 is there, and there is a resistor 1 kilo ohm. This is 3 volt, 8 volt. This is diode D2, this is 1 kilo ohm, and these two is connected to 10 kilo ohm. Now what is the assumption? So first step one is assume both D1 and D2 are in forward bias. So whenever these are in forward bias, we need to make both are short circuit. So that means current should flow from like this. Similarly, another diode D1, this is diode D2, both are short circuit, so current should flow. Suppose if I assume I1, this is I2, this is 3 volt, and here there is a 1 kilo ohm, this is 1 kilo ohm, this is 10 kilo ohm. Now how to find this I1 and I2? Now it's very easy. Three resistances are 2 independent sources. So if I assume some voltage source V here, now from the network analysis, if you apply a nodal analysis at this V, so V minus 8 by 1 kilo, similarly V minus 3 by 1 kilo, V minus 0 by 10 kilo. So that is V minus 8 by 1 kilo plus V minus 3 by, it is like this, 3 by 1 kilo plus V by 10 kilo equal to 0. So this is the nodal analysis. Now from this I can find easily V. So kilo are common, so I can cancel. This is 2V plus V by 10 is equal to minus 8 minus 3, it will become 11 volt. So what is this? So 20 under 21 V by 10 is equal to 11. So V is equal to 110 by 21. This is the voltage at this node V. If we find what is this 110 by 21, 110 by 21 is equal to, it is 5.24 volt. So that means we are getting here is 5.24 volts. Now it is easy to find what is I1 and what is I2. Now if you find I1 is equal to, so this is the voltage difference is 8 minus here is 5.24. So 8 minus 5.24 by 1 kilo ohm. So it is a positive only. So positive in the sense, so whatever we assumed, that is I1 is flowing from anode to cathode. But if you see in the second path, it is 3 volt here, but at the V is 5.24. So what is I2? I2 is 3 minus 5.24 by 1 kilo. So 5 minus 5.24 is higher than the 3 volt, right? So you will get minus value. So minus 2.24 by 1 kilo. So 5 minus 2.24 milliampere is flowing. That is, we assumed this direction, but it is flowing in the opposite direction, current. So what is that meaning? Whatever we assumed, diode D1 is in forward bias, but diode D2 is in reverse bias. So that is the conclusion we need to make. So since I1 is positive, so diode D1 is in forward bias, but I2 we got is negative, and so we say diode D2 is in reverse bias. So this is how we can easily identify which diode is in forward bias, which diode is in reverse bias, using short circuit method, right? So this is one type of gate problem you will get, oftenly. So maybe 2 times 3 times we got up to now, right? Sorry, we can from this problem we can